Okay, so let's have a look at an exam question to do with chi-square tests. Okay, so chi-square tests are to do with two-way tables, and again, it's sort of similar to Pearson's in the sense that it's looking to see if there's a connection between two different things. So here we have, it says in a study of 100 students, there seemed to be a difference between males and females in their choice of favourite car colour. The results are given in the two-way table below. A chi-square test was conducted. So we have favourite car colour, blue, red, green, and then the genders, males and females, and so on. And I mean, this table looks pretty neat because there's no extra information which some of the later exam questions have, but I'm going to fill them in anyway. Right, so first of all it says write down the total of male students, total number of male students. Well, if you think about it, we have 14 who said blue, 6 who said red, and 8 who said green. That's how many males we had. And if we add those numbers together, then we must have, well, let's just put total here for starters. Then there must be 28 male students altogether. 14 blue, 6 red, and 8 green. So that's 28 there. Okay. Right, now it says show that the expected frequency for males who chose favourite car colour is blue is 12.6. So what we're asked to do is work out an expected frequency. Okay, so what you'd expect to see. But what we need to do is fill in the various numbers. We need some totals first of all. So if we divide this up, okay, so we know there's 28 males in total, but if we add these ones up, 31, 24, 17, that means there was 72 females. Actually, let me do that in a different colour. Okay, so there was 72 females altogether, but then if we add those up together, 28 and 72, that comes back to the 100 students we have. Now, the other thing we need to do is we need to add up these to work out the expected, we add up the columns as well to work out the expected frequency. So we need to total the columns first of all as well. So 14 and 31 makes 45 here, and these two together make 30, and these two together make 25. And then what we should do is just double check, does this plus this add up to 100? And yes, it does, so that's fine. Okay, so both directions add up to 100, which is what we want because we have 100 students. Right, now let's work out the expected frequency for males whose favourite car is blue. Right, because we're dealing with males, and we're looking at favourite car colour being blue, that means it's to do with this cell here. So we need to work out the expected frequency of that cell. So the way to do it is we need to use the column total for that cell, so it's 45 total there, and the row total, which is 28, and then the total in altogether, so there's 100 people. So we need to use these three numbers to work out that expected frequency of that cell there. So we need to do basically 45 times 28, so the column total times the column total divided by, and then how many people we have altogether, so the bottom here, which is 100. And then if we work that out on the calculator, we do actually get 12.6 exactly. So you need to show this working to get those 2 marks there. Okay, so that's expected frequency. So even though it didn't have these totals in, we need to basically write those in. Well, we didn't need to do all of them really. We just needed to know the row total here and this total here. Okay, right, now let's look at this. First of all, in this particular question I chose, it actually tells you what chi-squared is already. It's 1.367, but what I'm going to do now is I'm going to show you how to actually work out chi-squared on the calculator. Okay, that's an important process. Right, first of all, what we need to do is, let me just clear all this stuff here. What you need to do to work out chi-squared is you actually need to just know this information here. And that's what we're going to enter into the calculator, this on our data here. We do not need the totals. Okay, don't need to know that, or the row totals, you don't need to enter them. So what they were, we don't need to them. We don't need to ignore all of this, ignore all of that. We just need to know this data here. And let's actually work out this number using the calculator so we're sure how to do that. So let's actually work out chi-squared. Okay. Right, so what we need to do is go to our calculator first of all, obviously, and you've got a choice of whichever one you want to use. You can use the Scratchpad Calculate or the Calculate down here. Either one will do. I'll just pick this one here down here. So we've got our regular calculator. Now, what we need to do is create a table, or what we call a matrix. So we go to Matrix, Create Matrix, and then the top one. So sorry again, so Matrix. So you press Menu, Matrix, Create, and then Matrix, and then let's create Matrix. Now, what we need to do is make a table exactly the way we see it on the question paper itself. Now, this, we're only concerned about these numbers here. So what we have is 2 rows, male, female, and then 3 columns. So what we want is 2 rows, that's fine, but we want 3 columns, and press OK. So we've got our table here. And then what we need to do is copy in these numbers here exactly the way we see them. So 14, 6, 8, and then 31 in this column, 24, and 17. Now, don't press enter just yet. What we need to do is store this in a letter. So we press Control, this button here where you got STO written in small, and it brings up this little arrow here. Now choose any one of the letters you want from the bottom. Any one will do. Let's just pick A and press enter. Now that letter A represents this matrix, this table now. So wherever you use A now, it's going to be this. And let's work out chi-squared and various other things. So go to Menu, go down to Stats, and then we want to go to the bottom one, Stats Test, and then we want to go to the one that says chi-squared 2A test. So you press that, and it says Observe Matrix, and we literally just type in the letter we gave the matrix and press A. And there we go. Here's our value for chi-squared. There's chi-squared, and it's 1.366, well 7, that's what they've got, 1.3667. That's how you work out chi-squared. And that's what you're going to need to do in the exam. Right, let's look at the next question. It says write down the null hypothesis. Null hypothesis is H0. Okay? And it's a short sentence, and it's pretty much the same thing. So, for every question. So what we need to do is look at our 2 variables. So our 2 variables are favorite car color and male and female, which we'll class as gender. Okay? So the null hypothesis is that, well, let's just say gender and favorite car color. I'll just write it short, favorite car. Let's just write it, actually, let's write it properly. Favorite car color are, and the null hypothesis H0 is that they are independent. Okay, so you write independent, that's the null hypothesis. The alternate hypothesis, I'll write it here, H1, which is the alternate one. Same thing, gender and favorite car color are, and we write, instead of independent, we write not independent. So that's the alternate hypothesis. So let's go through that again. So null is they are independent, and alternate is that they are not independent. Okay, so that's that question sorted. Okay, right, now let's look at the next question to work out the degree of freedom. Okay, the degree of freedom. Right, degree of freedom, what you need to do is look at your table, and you need to see how many rows you have. Okay, so we have, again, we ignore any titles, columns or totals, we just want the data itself. We have 2 rows, male and female, and we have 3 columns. So we have 3 columns, okay, and the degree of freedom, DF, is a simple formula. It's the number of rows, take away 1, times the number of columns, take away 1. You just work that out. Okay, so we've got 2 rows, and we have to take away 1 from that, and then we're going to multiply by 3 columns, and we're obviously going to take away 1 from that. Well, 2 take away 1 is 1, times 3 take away 1 is 2, and then 1 times 2 is 2, so that's your degree of freedom, so that's just 2. Okay, so and it's this simple formula you need to remember, okay? You need to remember how to use row take away 1, number of rows take away 1, times number of columns take away 1. Okay, right now, let's actually, right now, this next question here. It says write down the critical value of chi-squared with a 5% significance level. Right. In the exams to come in 2014, you will not need to do this bit here. You will never need to write down the critical value. Okay, that was the previous syllabus. This next syllabus, that's going to be done for you. So they'll have the number written. What you'll probably be expected to do is to work out chi-squared itself. But the critical value is 5.99 for this table based on a degree of freedom 2 and a 5% significance level. 5.99 is the critical value. Okay. Right, so now what it says is determine whether the null hypothesis should be accepted or not. Right, now this is how it works, okay? So if your, let's say critical value is k, let's say 5.99, okay, I'm going to give it the letter k. If your chi-squared value is less than or equal to k, okay, so the critical value, which would be 5.99 here, we do not reject the null hypothesis. Okay, so that's what you would write if this is smaller than this, and that's the case for us because 1.367 is definitely smaller than 5.99. Therefore, we do not reject the null hypothesis. Okay, but if it was the other way around, if chi-squared was greater than the critical value, so if it was bigger than this 5.9, then we reject we reject the null hypothesis. That's what you would write. Okay. So again, if it's less than or equal to the critical value, we do not reject HO. If it's greater than the critical value, we reject the null hypothesis. So in our case, we reject it because it's smaller than the critical value, which is 5.99. Okay, last thing I want to show you is on the calculator. They may ask you to do this, but on the calculator, you've got extra information. You've got this thing called, oh, by the way, sorry, there's DF, there's degree of freedom too. Oh, and the other things, oh no, I'll get back to them in a moment. The p-value is 0.504887, okay? What they may ask you to do is decide whether the null hypothesis is rejected based on this value instead, this p-value here, okay? Now let me just write that down, 0.505, let's round it to that, so many decimal places, okay, so 0.505, okay, so 0.505 is the p-value, okay? Now, to decide whether you reject the null hypothesis based on this p-value instead, is you look at the significance value they've quoted, 5%. Okay, 5% as a decimal is 0.05, okay? Now, if this p-value, if I just put p-val, is less than that critical value, so 0.05, then we reject HO. If it's greater than that critical value, then we do not reject HO. So our p-value, according to the calculator, is 0.505, which is definitely greater than 0.05, so we do not reject HO, just like we decided before. Okay, so remember those inequalities, okay, and which way around they go, because they're very important. They will not be in your formula booklet, so you're going to have to remember when you reject them and when you accept them and so on. Okay, and that is pretty much chi-squared in a nutshell. So remember how to do it on your calculator and remember the inequalities.